Okay, in our first example, we want to take the number 770,000 and we want to turn it into scientific notation. So if we remember the first step, what decimal place is, and that would be right there in the number. And we want to remember that this number is basically like saying this, 770,000 with the decimal place there. We can think of it as saying times 10 to the 0 because that's the same thing as saying times 1, right? But we just leave it out because it's not necessary. And so then the thing we want to do is we want to move that decimal place over so that it is located in between the first non-zero number and the number just to the right of it. We want to count how many times it took us to move to that place value, how many place values it took us to move there. And so it took 1, 2, 3, 4, 5, and 6 movements, 6 place values. Then we ask ourselves how many movements it took, which is 6, and in what direction. The direction was to the left, and so our little saying was, okay, if it's to the left, that's L, that means larger in value for our exponent. So that's up the number line from 0, a larger value for our exponent. So it needs to become 10 to the 6th positive 6th. So our final answer will be 7.7 because that is where our decimal point was moved to. We drop zeros times 10 to the positive 6. There are no units of measurement for this answer, so that is our final answer. Okay, for our second problem from the video, we had what is 0.000342 expressed in scientific notation. So I'm going to rewrite it just like we did for the other one. Once you get good enough at these, you won't need to rewrite them. But for now, I'm going to do it as we're still trying to remember how to do these. And again, I'm going to write it out as if we had 10 to the 0 just to help us remember what direction to change our exponent in, making it positive or negative when we move our decimal point. So if I've rewritten it this way, remember the first step now is to get that decimal point moved and count the steps it took to move it in between the first non-zero number and the number just to the right of it. So it took me 1, 2, 3, 4 place values, and I moved it to the right. Now remember, if I move it to the right, that means I need to reduce the value of the exponent, which means I need to go more negative from the value that my exponent already is. So if I start at 0 and I go down 4, or more negative 4, I end up with the negative 4th as my new exponent. So my number in scientific notation will be 3.42 times 10 to the negative 4. Alright, for our next problem, we're going to now do some addition and subtraction scientific notation math. We're going to perform the indicated operation, which is subtraction. So we want to remember that when we're doing addition and subtraction scientific notation math, our first step is to take a look at our exponents and make sure that they match. And if they don't, we need to make sure that they do by changing the exponents and moving the decimals respectively. So we can either change the negative 4 to negative 5 by moving decimals around in the first number, or we can change the negative 5 to a negative 4 in the second number by moving decimals around. I'm just going to address the first number. That's just what I always do. I just change the first number. So if you want to change that to negative 5, what we have to ask ourselves, did I reduce the value of the exponent, or did I make the value of the exponent larger? Well, negative 4 going to -5 is a reduction in value. So that is a rightward movement. So if I reduce the exponent, then I have to move the decimal point to the right. Okay? And so I'm moving it down in value by 1, which means I move the decimal point over 1 place value. So now my new number is 87 times 10 to the -5. And that is going to be subtracted by 6.5 times 10 to the -5. And so that's the math I'm doing. Okay? And so we then have to do 87, and you can use a calculator if you want, just to make your life easier, or you can do it in your head. And we get 80.5. And remember, this part is just carried down. There's no subtraction being done with those numbers. And that's our new answer. But remember, we always want to express our final answer in proper scientific notation. And proper scientific notation has the decimal point just to the right of the first non-zero number. So what did I just do? I moved my decimal point to the left, which means I need to make the exponent larger in value. Larger in value becomes closer to 0, so this needs to come up to -4. So my final answer will be 8.05 times 10 to the -4. Okay, so like the last problem, we are going to be doing subtraction. So the step number 1 is the same. We want to make sure our exponents are the same. We have -4 for the first, we have -5 for the second. I'm going to change the first number to make it -5. So again, we are going to be reducing the value, which means a rightward movement of our decimal point by a value of 1. So we're going to move it over 1. So this time we're going to have 14 times 10 to the -5 minus 5.3 times 10 to the -5. We perform our subtraction. We get 8.7 times 10 to the -5. What's nice about this is it's already in proper scientific notation. So that is our final answer. Our next problem is going to be a division problem, which follows the same rules as multiplication with scientific notation. So let's go through this one together. Remember, the first step in multiplication and division problems is not to focus on the exponents, but to just carry out the operation with what we call the front numbers. So remember, when we say the front numbers, we're talking about these right here. So if we're doing division, we're just going to go straight ahead and do 5.3 divided by 10.5. And with a little bit of rounding, I'll round to the nearest hundredths place. We get 0.50. Now that we've done that, we focus on the exponents. We have a -3 and we have a -6. And we want to remember that there's two different rules for multiplication and division. When it's division, we subtract the two. When it's multiplication, we add them. So we're subtracting. And I put these in parentheses because we always want to be careful when it's subtraction, because like in this problem, if we have a negative exponent, we subtract away a negative. What does that actually do? Well, we're actually essentially adding it, right? So negative 3 minus negative 6 is the same as negative 3 plus 6. So what we end up with is 3. And that's going to become the exponent when we put these together. So what do? We take this number, 0.50, and it's going to become multiplied by 10 to our new exponent, which is 3. Now, sometimes that will be our final answer, but those of you who have caught it, we remember that this decimal point has to be just to the right of our first non-zero number for it to be in proper scientific notation. So we need to take care of that. So we move this to the right, 1 place value. Rightward movement means we reduce the value of the exponent, right? So we reduce this by a value of 1, so it becomes 2 instead. So our actual final answer is 5.0 times 10 to the 2, right? It's worth noting that in the actual problem from the previous video, they didn't round, so it was 5.048 times 10 to the 2. And the other thing is we want to make sure we don't forget our units of measurement. So if we're doing grams in liters, then we're doing grams divided by liters. So we would write that grams per liters. All right, for our final problem from the video lesson, we are going to be multiplying two numbers in scientific notation. Remember, we're going to deal with the front numbers first. And so we're going to carry out the operation, which again is multiplication. So we're just going to do 5.24 times 3.8 that'll get us 19.912, so I'll just do 19.9. 19.9. All right, now we deal with the exponents. Remember, for multiplication, we are adding the exponents instead of subtracting them. Right, so negative 4 plus negative 19 is just negative 4 minus 19, right? That gives you our new exponent of negative 23. We put our number together, 19.9 times 10 to the negative 23rd. Of course, we're not in proper scientific notation, so we're going to the left one place value, which means we need to make the exponent's value larger by 1. So we're going to go closer to 0, which will turn that into negative 22. Let's rewrite it for our final answer. 1.99 times 10 to the negative 22. Let's not forget our units of measurement. So we're multiplying, so we have a meter multiplied by a meter, which squared, right? Meter squared. So final answer, which let's see what our, they didn't round as much as I did in the activity, so what they had in the activity was 1.976 times 10 to the negative 22. So if you want to be super precise without rounding, that's what they got, but for our purposes, this is just fine.